Have you ever found yourself spellbound by the mystical colors dancing in the sky, known as Aurora Borealis? This spectacle, more commonly referred to as the Northern Lights, has captivated human imagination for centuries, inspiring countless legends and myths across diverse cultures. Its ethereal beauty stirs emotion, invoking a sense of wonder and awe. This celestial ballet, however, is not just a random display of artistry. But what if I told you these magical lights are not just celestial artwork, but a result of fascinating scientific phenomena? The story of Aurora Borealis begins with our very own star, the Sun. The Sun, a fiery ball of gas, is constantly bursting with activity. During these outbursts, the Sun emits what we call solar wind. This isn't a wind in the sense we're used to on Earth. Instead, it's a stream of charged particles flung outwards from the Sun at incredible speeds. Now imagine these particles, like a cosmic fleet, embarking on an interstellar journey through space. Their destination? Our home planet, Earth. But Earth, with its protective shield, the magnetic field, doesn't let these particles storm in uninvited. The magnetic field, a guardian of our planet, guides these particles towards the poles, where it's weaker. As these particles approach the North and South poles, they start to interact with the gases in our atmosphere. This interaction, this meeting of cosmic and earthly elements, creates a spectacle that leaves us in awe. The sky lights up, and we witness the ethereal beauty of the Aurora Borealis. So these seemingly magical lights are the result of a cosmic dance between the Sun's energy and Earth's magnetic field. But how does this dance create such mesmerizing colors? The secret to the aurora's enchanting colors lies in a process you might remember from your high school science classes: excitation and de-excitation. So what exactly happens here? Well, when particles from the Sun, known as solar wind, collide with atoms in our Earth's atmosphere, they transfer energy to these atoms. This extra energy excites the atoms, causing them to move to a higher energy state. But atoms prefer to be relaxed, so they don't stay excited for long. When they return to their normal or ground state, they release the extra energy in the form of light. This process is called de-excitation. Here's where it gets colorful. The color of the light emitted during de-excitation depends on the type of atom and the amount of energy it releases. The Earth's atmosphere is primarily composed of oxygen and nitrogen atoms. Excited oxygen atoms emit green or red light, depending on their altitude and the degree of excitation. Nitrogen, on the other hand, can emit blue or purple light. So, when you see the sky painted with these magical lights, you're actually witnessing millions of these tiny light emissions from de-excited atoms. It's a grand spectacle of nature's light show, meticulously crafted by atmospheric gases and powered by solar energy. So the next time you see a green, purple, or red light show in the sky, remember, it's the Earth's atmospheric gases putting on a performance. From ancient myths to modern science, the Aurora Borealis continues to captivate us all. This ethereal display, often known as the Northern Lights, is not just a feast for the eyes, but also a fascinating result of a cosmic dance between the Sun and the Earth. So let's take a moment to unravel the beauty behind these shimmering curtains of light. It all begins about 93 million miles away, on the surface of our Sun. When the Sun hurls a storm of charged particles into space, a phenomenon we call a solar wind, these particles embark on a journey towards our planet. As these charged particles reach the Earth, they are drawn towards the poles by our planet's magnetic field. This is where the real spectacle begins. Upon colliding with the different gases in our atmosphere, these particles illuminate, creating the mesmerizing light show we know as the Aurora Borealis. The different colors of the aurora are a result of this interaction with various gases. Oxygen gives us the green and red hues, while nitrogen contributes to the blue and purple shades. Each display, unique in its arrangement and intensity, is a testament to the ever-changing conditions in space and our atmosphere. So the next time you gaze upon the magical Aurora Borealis, you'll know the fascinating science behind this breathtaking spectacle. Until then, keep looking up and keep wondering.